this is lesson 10.5. So in this lesson, we're going to be talking about how to find the area of a polygon using a coordinate plane. So coordinate plane, if you remember from algebra, is just like a grid, a coordinate grid that has an x and y axis. So let's start by looking at formulas, area formulas that we've seen before. So the first one is a triangle. How do we find the area of a triangle? We find, or we multiply half times the base times the height of the triangle. So just knowing base and height and taking half, that gives you the area of the entire triangle. To find the area of a rectangle, it's just the base times the height. To find the area of a parallelogram, it's also base times the vertical height. So just make sure that the height is the vertical height. Now for a rhombus, to find the area of a rhombus, what we do is we find half of the diagonal times the other diagonal. So you're multiplying the two diagonals and then taking half. Same thing for a kite. Multiply the two diagonals and then take a half. And then for a trapezoid, to find the area of a trapezoid, you take the sum of the two bases, times it by the height, and then take half. So in this example, we're given a figure, and we have to determine what is this figure. Is it a triangle, rectangle, parallelogram, trapezoid, rhombus, or kite? So this figure is a parallelogram. This looks exactly like this. How do we find the area of the parallelogram? We find the base of the parallelogram times the vertical height. So let's look at this together. What is the base? That's the distance from D to C. So what we do is we count the squares. So there's 1, 2, 3, 4. So this is 4. And then the height is the vertical height. So if I was to draw a dotted line down here and I count the squares, 1, 2, 3, that is 3. So area is equal to 4 times 3, which is 12 units squared. Okay, next, let's look at this figure here. So we have a figure, and in this figure we have different triangles. We have triangle A, triangle B, triangle C, and triangle D. So they actually already did the first one with us, but let me walk you through how they did it. To find the area of triangle A, what they did was they found the base. So the base is here, and they counted 6 units. So 1, 2, 3, 4, 5, 6. And then the height is 2. So the formula for a triangle is 1/2 base times height. 6 times 2 is 12, and half of 12 is 6. So they get 6 units squared. They want you to apply this for triangle B. So again, for this triangle, we need to determine what the base and the height is. So let's look at this as the base. The base would be 3 units, and the height would be 1, 2, 3, 4 units. So the area is equal to 1/2 3 times 4. 3 times 4 is 12, and half of 12 is 6. So this is also 6 units squared. For triangle C, let's call this the base. So this is triangle C, and the base is 1, 2, 3, and the height is 2. So the area is equal to 1/2 of the base times the height. So 3 times 2 is 6, and then half of 6 is 3. So this would be 3 units squared. Okay, let's look at triangle D. So the base would be 1, 2, 3, 4, 5, 6, and the height would be 1, 2, 3, 4. So 1/2, 6 times 4. 6 times 4 is 24, and then half of 24 is 12. So this would be 12 units squared. Okay, so the next part of this lesson is finding areas of composite figures. So let's talk about the definition of a composite figure. A composite figure is made up of simple shapes such as triangles, rectangles, and parallelograms. To find the area of a composite figure, find the areas of the simple shapes and then use the area addition postulate. You can use the area addition postulate to find the area of a composite figure. So let's first look at this, and this is a composite figure. If you look at this figure, it's a quadrilateral, but it does not look like a triangle, does not look like a rectangle, a kite, or trapezoid. But what we could do is we could break this composite figure into multiple pieces so that we can find triangles, rectangles, or parallelograms in this figure. And what we're going to be doing is something called the area addition postulate, where we're going to find the area of each shape, and then at the end, take the sum of each shape to find the area of the entire composite figure. So, take a minute to look at this figure. What shapes can we create from this figure? So what I see is I could create 2 triangles. So if I was to bring this line down, do you see how we have a triangle ADC and a triangle ABC? So now that I have 2 triangles, I know how to find the area of a triangle, and that is 1/2 base times the height. So let's start with triangle ADC. What is the base? We count down. So there's 1, 2, 3, 4, 5, 6. And then the height would be 1, 2, 3. And then we see this here. The area of triangle ADC is 1/2 of 6 times 3. And then we could do the same thing for triangle ABC. So we know the base is 6 because they share the same base. And then if you want to find the height, we would count 1, 2, 3, 4, 5, 6. So also 6. The area of ABC would be 1/2 6 times 6. And let me just walk you through the math. 6 times 3 is 18. Half of 18 is 9. 6 times 6 is 36. Half of 36 is 18. And then we take the sum of those two pieces. 9 plus 18 is 27. So kind of to recap, or kind of just to reflect on what we just learned, take a minute to explain in your own words what a composite figure is. So make sure you understand that definition. What is it in your own words? And then how do you find the area of the composite figure? So we're going to learn a different way of finding the same area of the figure. But in this method, we're going to be using subtraction. So this composite figure is the same figure that we were given. What we're going to be doing is using the vertexes of, so using the points of the figure that was given, we're going to create a rectangle around this figure. So there's a rectangle around this figure. Creating a rectangle around this figure gives us 4 triangles that we created. So A, B, C, and D. So what we could do is we could find the area of the entire rectangle, and again that is the base times the height, and they got 9 times 6, so they counted 9 times 6, and they got 54. So the area of this entire piece is 54. But we don't want to find the area of this entire piece. We only want to find the area of this shape right here. So what they do is they subtract each triangle to find the final area. So here are the areas of each triangle. Triangle A is 6, triangle B is 6, triangle C is 3, and triangle D is 12. So we take the whole area of the rectangle minus each triangle, and then we end up with the same 27 units squared. This is just another way of doing the same problem using subtraction. Okay, so now let's practice doing some of these problems. So in figure 1, let's use the area addition postulate. What shapes do you see in this composite figure? And outline those shapes. So what I see a square right here. I see a triangle right here. I see another triangle here. And then I see another triangle there. So I'm going to call this square A, triangle B, triangle C, and then triangle D. And then I'm going to find each piece, so square A. To find the area of square A, we find the base times the height, so 4 times 4 is equal to 16 units squared. Next, we're going to look at triangle B. So the area of triangle B, and the base is 4 and the height is 3. So formula for area of a triangle is 1/2 the base times the height. 4 times 3 is 12, half is 6. So this is 6 units squared. Then triangle C is, let's say the base is 4, and then the height is also 4, I think. 1, 2, 3, 4. So this would be 1/2. 4 times 4. 4 times 4 is 16, and half of 16 is 8. So this would be 8 units squared. And then triangle D. Let's call this the base. The base is 2, and the height is 4. So we have 1/2, 2 times 4. 2 times 4 is 8, and half of 8 is 4. So then what we need to do is take the sum of these. So 16 plus 6 is 24. 24 plus 8 is 32. 32 plus 4 is 36. So this would be 36 units squared. Okay, and then number 2, so let's look at this figure and let's determine to see what should we use. Should we use the area addition postulate, or maybe we should do subtraction? If you do decide to use the area addition postulate, you need to make sure that you are able to create shapes in this figure. So either triangles, squares, rectangles, or kites. So I'm looking at this figure and I'm trying to see where can I cut this figure so that I could create 2 perfect triangles. See, if I cut the figure down here, I have 1 perfect triangle, but then this figure on top is not a triangle. I think the best option for this one is to create a rectangle around this figure. So let me draw. Hopefully you guys could see the rectangle I'm drawing. So I'm just drawing a rectangle around this figure. So this is my rectangle. Here and here. It's kind of hard to see this one here. So I have a rectangle around this figure, and then I have 4 triangles that were created. I have triangle A, triangle B, triangle C, and triangle D. So let's start by finding the area of the rectangle. So the base of the rectangle would be 1, 2, 3, 4, 5, 6, 7. The height of the rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 times 9 is 63, so this is 63 units squared. So then let's look at triangle A. What is the area of triangle A? So the base, let's say it's 1, 2, 3, 4, 5. So 1/2 base, and the height would be 1, 2, 3, 4, 5. So then we get 25. 5 times 5 is 25, and half of 25 is 12.5. Triangle B. So the base would be 1, 2, 3, 4, and the height would be 1, 2, 3, 4. So half of 4 times 4. 4 times 4 is 16, and half of 16 is 8. So this would be 8 units squared. Triangle C. So we have the base is 1, 2, 3, and the height is 1, 2, 3. So 1/2, 3 times 3. 3 times 3 is 9, and half of 9 is 4.5. And then triangle D. So the base would be 2, so 1, 2, and then the height would be 1, 2, 3, 4, 5, 6. So 1/2 times 2 times 6, and 2 times 6 is 12, half of 12 is 6 units squared. So we have the total area minus each piece, and let's do that on the calculator. So we have 63 minus 12.5 minus 8 minus 4.5 minus 6, and that gives us 32. So I'll put our final answer here. The area of the composite figure is equal to 32 units squared. And that's the area of this figure here. So to recap, we use subtraction, we use addition in this problem. Okay, so that ends lesson 10.5. Now for the homework, what we need to do is we need to find the area of these composite figures. If you are doing this on a separate sheet of paper, try your best in showing all work. You don't need to draw the figures. You could just use the PDF document to create your shapes. And just do all work on a separate sheet of paper. And then you have the 10.5 checkpoint. All right, well, have a good day, guys.